So welcome students. In this video, we're going to look at some of the important simplifications that you'll need to do in problems. So the first set is the set containing tan pi by 4 plus theta and tan pi by 4 minus theta. So in the questions, whenever you get tan pi by 4 plus theta, what you can write is 1 plus tan theta by 1 minus tan theta. This is very easy to derive. I'm just using the formula of tan of A plus B. Tan pi by 4 plus tan theta by 1 minus tan pi by 4 tan theta, and tan pi by 4 is equal to 1 because it is 45 degrees. So whenever you have tan pi by 4 plus theta, you can write as 1 plus tan theta by 1 minus tan theta. Not just this, you should be able to write it in the reverse also. Whenever you see 1 plus tan theta by 1 minus tan theta, you should be able to understand it as tan pi by 4 plus theta. Similarly, the case of tan pi by 4 minus theta, 1 minus tan theta by 1 plus tan theta. So these are two important simplifications that you can do in questions. And next set is sin theta plus cos theta. Whenever you have sin theta plus cos theta, if you want to convert it into a single trigonometric ratio, if you want to go from two terms to one term, what you can do is you can divide it with root 2 and multiply it with root 2. And once you divide this with root 2, 1 by root 2 is sin 45 as well as cos 45. So if you write it as cos 45, sin theta cos 45 plus cos theta sin 45 is sin 45 plus theta. So I can write as root 2 times sin 45 plus theta, or if I convert it in the form of cos theta, I can write as root 2 times cos of pi by 4 minus theta. So both of them are valid. Similarly, sin theta minus cos theta, if I do the same thing, divide by root 2 and into root 2. And 1 by root 2 can be written as either sin 45 or cos 45. Depending on what you write, you get the formula as root 2 times sin pi by 4 minus theta, root 2 times sin pi by 4, cos pi by 4 plus theta. So remember these expressions, sin theta plus cos theta and sin theta minus cos theta. They can be simplified like this. Next, the third set is if you have root of 1 plus sin 2 theta. This expression is a very standard expression. 1 plus sin 2 theta. So this, what you can do is 1 can be written as sin square theta plus cos square theta. That's an identity. And sin 2 theta can be written as 2 sin theta cos theta. That's a multiple angle formula. Now this expression inside root looks like a square plus b square plus 2ab, which is a plus b whole square. And square root and square gets cancelled to get mod of sin theta plus cos theta. Remember that you need to put a mod here because positive square root of x square is mod x, not x. So if you don't put mod here, sometimes you might get wrong answers. Similarly, root of 1 minus sin 2 theta can be written in the same way to get mod of sin theta minus cos theta. If sin theta minus cos theta is positive, then that will be the answer. If sin theta minus cos theta is negative, the answer will be minus of sin theta minus cos theta. So you get the positive square root of this number outside. Next, if you have root of 1 plus cos 2 theta, this is sin 2 theta. So whenever you have sin 2 theta, we usually write 1 as sin square theta plus cos square theta. Get this. And now once you have this, if you want to convert this into a single trigonometric ratio, you can use this also. You can use this formula to write it as root 2 times mod of sin pi by 4 plus theta, so on. Similarly, if you have 1 plus cos 2 theta, cos cannot be written as 2 cos theta sin theta. So here what we do is we use the formula 1 plus cos 2 theta is equal to 2 cos square theta. And root of this is root 2 times mod cos theta. Root of 1 minus cos 2 theta is root 2 times mod of sin theta. So these simplifications occur very often in your questions. So make sure that you take note of all these 4 simplifications and remember them before going into the problem section. So in this video, let us look at the logics of these 7 secret formulas. So let us try to explain the first one. Sin A into sin 60 plus A into sin 60 minus A is equal to 1/4 of sin 3. So let us see why this is happening. So sin A times sin 60 plus A, I can use compound angle formulas for this, or sin A plus B into sin A minus B. So we have the formula sin of A plus B
into sine of A minus B is equal to sine square A minus sine square B, right? Sine square A minus sine square B. We have already seen this in advanced formula. So sine A plus B into sine A minus B is sine square A minus sine square B. Now sine 60 plus A into sine 60 minus A is nothing but sine square 60 degrees minus sine square A. So that is equal to sine A times sine square 60. Sine 60 is root 3 by 2. So sine square 60 is 3 by 4 minus sine square A. If I take the LCM here, that is equal to 1/4 of sine A times 3 minus, if I take LCM, 4 sine square A. And this is equal to 1/4 of, if I multiply the bracket, so if I have this, I get 3 sine A minus 4 sine cube A, right? That is equal to 1/4 of 3 sine A minus 4 sine cube A. In the topic of multiple angles, we have seen that this is the formula for sine 3. So sine A into sine 60 plus A into sine 60 minus A is equal to 1/4 of sine 3. So in the same way, you can derive the formula corresponding to cos and tan also. Once you derive cos, if you divide the first equation and second equation, you get the formula for tan. So I hope you have understood the first 3 secret formulas. So let us look at the second formula now. Second formula is cos A into cos 2A into cos 2 square A into cos 2 cube A, so on up to cos 2 power n minus 1 times A is equal to sine 2 power n A times 2 power n sine A. So let us try to prove this. So what I try to do is, I'll cross multiply this and prove that 2 power n times sine A times this expression is equal to sine 2 power n A. That's the logic I'm going to use. And the formula that I want you to remember is sine 2A is equal to 2 sine A cos A. I hope you remember this multiple angle formula. Sine 2A is 2 sine A cos A. That is, if you have an angle here, the angles that come here are half of these angles. If you have 2A here, you get A and A. Conversely, if you have A and A here, you get twice of that angle inside side. So if you multiply this with the LHS, so you have 2 power n times sine A times cos A cos 2A cos 2 square A, so on, cos 2 power n minus 1 times A. So how many terms are there here? From cos 2 power 0 times A, 2 power 1 times A, 2 power 2 times A, so on up to 2 power n minus 1 times A. From 0 to n minus 1, you have n terms. So this constitutes n terms. So now what I do is, what is 2 power n contains n 2's, 2 into 2 into 2 into so on up to 2 n times. Now you take one of these two with sine A and cos A. So what happens? 2 sine A cos A is sine 2A, and you take the next two with 2 sine 2A and with cos 2A. What happens to this? So this becomes sine 2 square A. Now take another 2 sine 2 square A into cos 2 square A will become sine 2 cube A. With the next two, sine 2 cube A and cos 2 cube A, you get sine 2 power 4A, so on. If you go on doing it like this, so you're going to get the last step, you get 2 times sine 2 power n minus 1A into cos 2 power n minus 1A is nothing but sine of 2 power n times A. So this is the logic for the second formula. So now let us look at the third formula, which is sine alpha plus d plus sine alpha plus 2d, so on up to sine alpha plus n minus 1 into d. If you have n terms in AP, if you have n angles which are in AP and you're asked to find the summation of sines of those, this is the formula. How is this formula valid? So what I try to do is, I'll multiply sine d by 2 with the LHS and show that it is exactly same as the numerator of the RHS. So what happens if you multiply sine d by 2 with this? So the LHS becomes sine d by 2 times sine alpha plus sine d by 2 times sine alpha plus d plus sine d by 2 times sine alpha plus 2d plus so on, plus sine d by 2 times sine of alpha plus n minus 1 times d. So I get the summation of all these terms. Now what I do is, I'll multiply all these terms with 2. So if I multiply all these terms with 2, I get 2 in each of this term. And later I'll divide by 2. So this is equal to, so now you get 2 sine A sine B. So what is the formula for 2 sine A sine B? That is cos A minus B minus cos A plus B, right? That is the transformation formulas from product to sum. So if you have 2 sine A sine B, so minus 2 sine A sine B is cos A plus B minus cos A minus B. So 2 sine A sine B will be cos A minus B minus cos A plus B. So cos of A minus B alpha minus d by 2 minus cos of alpha plus d by 2. So in cos it doesn't matter whether you use A first or B first, because cos of minus theta is cos theta. That is equal to cos of A minus B alpha plus d minus d by 2 is alpha plus d by 2 minus cos of alpha plus 3d by 2. So this is equal to cos of this minus this is alpha plus d by 2d minus d by 2 is 3d by 2 minus cos of alpha plus 5d by 2. So on this goes on. And finally you get cos of this minus this alpha plus n minus 1 times d minus d by 2. This is 2n minus 2 times d by 2. 2n minus 2 times d by 2 minus d by 2. That is, you get 2n alpha plus 2n minus 3 times d by 2 minus, if you add these two, you get cos of alpha plus 2n minus 2 times d by 2 plus d by 2. It is 2n minus 1 times d by 2. So if you add all this, so can you see some cancellations? So as you can see, cos of alpha plus d by 2 minus cos alpha plus d by 2. These two are getting cancelled, these two are getting cancelled, and the sequence follows and all these get cancelled. So if you add all this, what is left out is cos of alpha minus d by 2 minus cos of alpha plus 2n minus 1 times d by 2. So what is cos c minus cos d? Cos c minus cos d is minus 2 sine c plus d by 2 into sine c minus d by 2. So minus 2 sine of this plus this by 2. So what is the summation of this? So 2 alpha and plus 2n minus 2 times d by 2 by 2. So minus 2 sine c plus d by 2 into sine of c minus d by 2. That is, if you subtract from this, alpha and minus alpha gets cancelled. Minus d by 2 minus of 2n minus 1 into d by 2. So you get minus of 2n d by 2. So that is equal to, so obviously you know that this 2 and 2 gets cancelled. From sine, a negative comes out, because sine minus theta is minus sine theta. This minus comes out and cancels with this. So you get 2 times sine of, if you cancel a 2 here, you get alpha plus n minus 1 times d by 2. This minus has already come out, so you have sine and d. So alpha, if you subtract this, you get 2n d by 2, by 2 from the formulas, because minus 2 sine c plus d by 2, sine c minus d by 2. C minus d is minus 2n d by 2 by 2. So you get n d by 2. So now initially you have multiplied all the terms with 2 and you got this formula. So what is the value of this? This is, you have to finally divide by 2. So this 2 gets cancelled. So you're getting sine alpha plus n minus 1 into d by 2 into sine n d by 2. So this is the logic for this formula. So you need to remember this formula very carefully, because you get the questions based on this very regularly. So the last formula is tan alpha is equal to cot alpha minus 2 cot 2 alpha. Why is this happening? So what I try to derive is 2 cot 2 alpha is equal to cot alpha minus tan alpha. So Formula can also be written as 2 cot 2 alpha is equal to cot alpha minus tan alpha. Is this valid? So 2 cot 2 alpha is nothing but 2 by tan 2 alpha. So let us simplify the LHS and let us simplify the RHS. If I get the same expressions, that means these two are equal. So 2 by tan 2 alpha is 2 by tan 2 alpha is 2 tan alpha by 1 minus tan square alpha. This 2 and this 2 gets cancelled. That is equal to 1 minus tan square alpha by tan alpha. This is a simplification of the LHS. So now let us look at the RHS. So RHS is nothing but cot alpha is 1 by tan alpha minus tan alpha. That is equal to, if you take LCM, 1 minus tan square alpha by tan alpha. So can you see that LHS and RHS simplifies to the same expression? Yes. Hence, these two are equal. 2 cot 2 alpha is equal to cot alpha minus tan alpha. Hence, this will be valid. So tan alpha is equal to cot alpha minus 2 cot 2 alpha. So this formula will be useful in very specific questions, which we are going to see afterwards in the question section. So I hope you have understood all the 7 formulas. So it's very useful to commit them to memory instead of trying to derive it whenever required.